Alright, welcome everyone. So this is going to be the second video on the lever rule. The last video was sort of irrelevant in the sense that we didn't actually get to the lever rule. Hopefully we will in this video. It's a very long process because there's a lot of concepts to go over, also a lot of details to go over before we get into actual rule, because it's actually not very easy to understand at first. So let's go back to our original problem. So what we had in the original video was we had an AB alloy system in which the temperature varied, and we had this hysteresis looking curve, and at this point we basically just had 100% weight alpha or A, and then 100% weight beta, B. And we said this was alpha and this was beta, and we defined alpha as, we said alpha was solid and beta is liquid. So in this region, obviously, you have them both. And so we calculated what this was, which we said was gamma 1. Now suppose we have to find the composition of phases where it's gamma 2, like we could just call it gamma 2. Well, the first thing you want to do is you want to lay out all the properties associated with it. So the properties associated with it are temperature, so temperature, and then also weight composition. We'll just call it weight, W naught. That's a good name for it because there's other things that we have to do associated with that, which we also have to call WA or alpha or whatever. So, okay, so the first thing you do when you want to find the temperature is you draw a horizontal line parallel to the abscissa, which U is the x-axis, and project it onto the, what do they call it? I don't remember, sorry. And so let's say like at this point we had 500, right, degrees Celsius. Here we had about maybe 400. Yeah, so this was, I don't remember. Anyway, so then we have to draw a vertical line, and we have to mark it, right? So not really mark it, I guess you don't have to mark it, but you just approximate what that is. So this is approximately 80%, right? So this would be 80% weight A. Now, in the last video I didn't really clarify, but basically the weight percentage and the composition are not always interchangeable. Sometimes they are, but you'll see from practice when they are interchangeable and when they're not interchangeable. So in this case, we're just going to assume for now that it's not interchangeable until I let you know that it actually is. So in the beta, so the first part of the problem is usually, remember, is to find the composition of the. So let's say if for the first problem for gamma 2, just as we did in the previous video, we said, okay, number 1, find the compositions of A and B. So in alpha and beta, remember, although this is 80%, it's not going to be the composite. The 80% is the weight composition of both liquid and solid together. So it's not going to help us a whole lot. The way we do this is we draw a lever. So the lever would be from one end. So what we're doing is we're marking, is basically, it's going to be along the horizontal line, but it's going to be from one boundary line to the next. So this is the lever. The whole lever is from one boundary line to the other boundary line. And so the boundary lines are the boundary curves for the alpha and the beta phases. And so it would be the where you mark the points are where it crosses the horizontal line associated with the 400 degrees Celsius temperature and the alpha and beta curves. So that's what I've done here. Anyway, so that's the first thing. Now you want to, at those points, you want to draw a vertical line so that you find out what the compositions are. So this is actually all you really need to do for number one, for this problem. Because, so let's say if this is 100%, right? Let's just say if this curve is like right here, and this was 100%, then this point would be about 97%. So this is about 97% for A, and this looks like about 40% for A, weight percent. So basically, because this indicates it crosses with alpha, that would represent the composition or the weight percentage in alpha. So what we say is in alpha, the composition of A is actually the weight percentage of A, because now it's interchangeable because of the fact that you have A or B, right? So you and A or B can lie in any region. So that's the reason why the composition is going to be the same as the weight percentage. So this would be 40%, and then chi B is going to be, you know, it's going 100 minus that, so 600%. So let me see what I'm doing on time, because YouTube actually deletes my videos if I don't do them in time. So anyway, we have this going. This basically answers the first part of the question. The second part is now we want to do it in B. Well, we just do the same thing, right? We just say, okay, well, here it's approximately 97%, remember? So it's just chi A is 97%, and chi B is 30%. So yeah, that's the first part of the question, our first problem. The second problem actually involves the lever rule. So far we've drawn the lever, and the only thing that has helped us out with is finding the compositions of the solid and the liquid. Well, but now the next question is, all right, so what if we want to find the composition of the phases themselves, right? Well, we can do that using these compositions. So are actually more like weight percentages, not really compositions, because yeah. I'll show you right now. So now, what if we ask that question, right? Well, let's figure that out. Number 2, find chi alpha. So what they'll basically say it in words is composition of alpha and beta. Now, see, remember earlier I said find the composition of phases, right? So if you consider these phases, that would be incorrect, because now this is a totally separate problem. Basically, this is equivalent to saying find the compositions of states, because if we're going to find the composition of states, we're specifically finding the composition of the states, right? Not necessarily phase, because the phase themselves they're describing the composition of the matter itself. So and the states too. So in order to do this, we use the lever rule. So let's say we want to find chi alpha, right? So the lever rule basically is that you find the weight percentage associated with the upper region of the lever. So you want to find its distance, right? So you're finding the length of the lever. So the length of the lever, we'll just call it L, right? Is just some number, right? And I'll get back to you on that just like in maybe a minute. So and so the numerator, and so that you're basically finding, and so what the length, it would be the denominator, because you're finding a fraction of the total length, which is gonna be the length of the lever. So now the numerator is a little bit confusing, because it's basically gonna be the length of whatever of the opposite end. So we see here that this distance looks like it should be associated with alpha, but it's actually the distance to the right that's associated with the state on the left. Do you see what I mean? So let me clarify this. The distance, when you're using the lever rule, the distance to the right is associated with the phase to the left, and the distance to the left is associated with the phase to the right. Eat those words up, like, I mean, I don't know what you want to call it, but make them biblical or whatever. Make them, make a law, basically make a law out of it. Do whatever you can so that you kind of get that idea in your head. Because to find the composition of alpha, it's associated with what's on the right side of the point that you're taking. So so the distance of that would be basically what you found. So the weight percentage of what you got earlier, which was this, which was the well, we could basically call it we could call it alpha because, or sorry, beta, because in beta, that's the weight percentage, right? 97%. So it'd be weight beta, which is the weight is going to be the abscissa, and you know, so, or just the x-axis, and minus the weight knot. Remember earlier, I don't know if you saw it, but, or if I even gave it to you, I don't remember. But the the weight knot is going to be just the weight associated with the point. So remember, it's just 80%. So the length, though, the length is going to be the total. So it's going to be this ends up being weight beta minus weight alpha, weight knot, and it's going to be divided by the weight of beta minus weight alpha. So you can see that weight alpha, this is weight alpha, so this is beta, and then this is weight alpha. And so if you subtract them, you get the distance. Can you see that? All right, so let's actually calculate this. Hopefully I can hurry up. So that's just going to be 97 minus what we got, 80, and divided by 97 minus 40. And so let's see what that is. I gotta hurry up. So this is about 30%. And so logically you can work out also that chi of beta is just going to be the complement, so it's just going to be 100% minus that, because you only have two phases. So you can kind of skip steps. Otherwise, you'd have to do this whole technique over again, which you don't want to do. Anyways, thanks for watching. Hopefully that helped.